morning. So again, I'm Mrs. Maria Cristina Armaser, your teacher on Grade 8 Earth Science for second quarter. Our next focus of discussion is all about layers of the atmosphere, all about the atmosphere. So firstly, we will discuss the different layers of the atmosphere together with their characteristics and properties. So we will begin with the troposphere. The troposphere is the first layer of the Earth's atmosphere where weather and climate changes and typhoon forms, cloud forms, and where we observe airplanes flew. Basic structure of the troposphere is that its elevation reaches up to 11 kilometers by height or by altitude. With this, as you go up the troposphere, or when you experience to go on higher altitude, there is a decrease of gases as you begin to grasp for air as you go to higher altitude. And likewise, it gets colder when you go to higher altitude, like when you go to Tagaytay or to Baguio. So those are some of the characteristics of the troposphere. Composition. The composition of the atmosphere is basically 78% of our atmosphere is highly made up of nitrogen. Secondly, which is just 21.9% is composed of oxygen, which is actually very important to us humans and likewise other low forms of animals in the animal kingdom requires oxygen to breathe, or is a requirement to one of the basic process in living thing, which is actually respiration. And then the rest and the remaining gases are actually carbon dioxide, which is actually a prerequisite of plants to process photosynthesis. And some inert gases such as argon, radon, xenon, helium, those are actually what we call as inert gases, or those gases found on the group 8A of the periodic table. Next layer is actually the stratosphere. Strato means it's layered. Okay? And this is the layer where it is considered to be hot, because when we are on the troposphere and as we proceed to the stratosphere, there is a drastic change of temperature, because on the highest portion of the troposphere, there the temperature drops. The temperature drops because the particles are few and are actually far from each other. Thus, the energy or the heat energy is actually spread, and likewise, it would be hard for this energy to transfer from one particle to the next, because the gas particles are actually sparse and actually spread as you go to higher altitude only on the troposphere. Okay, that is the layer that is closest to us here on the ground. While stratosphere, as we proceed to the next layer, which is stratosphere, will experience a drastic change in temperature, because on the stratosphere, the ozone layer is located on the stratosphere. We do know that the ozone layer is the one responsible for absorption and filtering the amount of radiation to be released to us on the lower level, or to be specific, here on the ground. So which means they are the ones responsible for the reduction and really the absorption of this energy from the sun. So we will not absorb 100% of radiation that is coming towards here or inside here on the lower ground. Next is actually the mesosphere. In the mesosphere, as I've mentioned a while ago, most of the gases are actually on the troposphere, as there is this cloud formation, typhoon formation, stratosphere, you have here the ozone. While on the mesosphere, as you can see, particles are really few. That is why from being hot in the stratosphere, on the next layer, again, there will be a change in temperature because since there are few particles, thus there will be few particles absorbing the heat that is coming from the sun. Thus, on the mesosphere, it is actually a cold region or a cold layer of the atmosphere. Next is actually the thermosphere, or the outermost layer of the atmosphere. It is divided into two, the ionosphere, and then the next one is the exosphere. Ionosphere, this is the region where most of the gases that escaped from the sun is actually trapped on this layer, and on this layer, this is the one responsible for having aurora borealis, and then aurora australis. So the movement, since they are actually magnetically attracted towards our north and then south poles, thus this aurora borealis, since they are actually charged particles, they are attracted to the north and south poles of the Earth. Thus, the aurora is just visible and can be observed only on the north and southern hemisphere of the Earth. Exosphere is the outermost layer of the atmosphere. They are the one who firstly received the heat that is coming from the sun. Okay? And this is where most of the satellites are located, and this is the portion where the temperature is really high, because the particles on this region will be the one to firstly absorb the energy from the sun. Okay? Next topic that we will discuss is actually factors. After discussing the different layers of the Earth's atmosphere together with its composition, we will discuss the elements of weather and climate. Let's differentiate the two. Weather is actually an occurrence, a change in the atmospheric condition for a specific period of time. Let's say for 30 minutes, 1 hour, 2 hours, or all throughout the day. But when we say climate, this is the totality. This is the totality of the atmospheric condition over a long period of time. So it is being recorded yearly, annually, or hundreds of years. So most of the scientists recorded this condition of an area, or of their atmospheric condition of this particular area for a longer period of time. Okay, so that's a big difference between weather and climate. And there are a lot of factors which affects weather and climate. So the first one is actually temperature. So as I've discussed the different layers of the atmosphere, again, I also discussed the temperature that is actually experienced by those traveling from the troposphere up to the atmosphere. Troposphere, as you go up the troposphere only, there is a drop down of temperature as you go to higher altitude, but on the troposphere level only. Next, as you go to the stratosphere, it gets hot because this is the region where Ozone is found in, it is responsible for the absorption of heat coming from the sun. Next is actually mesosphere, which is cold. And then the thermosphere, wherein it is hot because it is the first one which absorbs the heat firstly coming from the sun. So again, these different layers are actually highly affected by temperature. So with this, our atmospheric condition or weather and climate condition on a particular area is highly affected also by temperature. So air temperature refers to the temperature readings made at ground level or here on our ground. Air temperature sensors such as thermometers and thermocouples are used for this purpose. Temperature changes as we go higher above the ground, just like what we experience when we go to Tagaytay or Baguio. There is this cold temperature as we go to higher elevation, because the main reason for that is as you go to higher elevation, the particles are getting far from each other. So there will be few particles as you go to higher elevation. That is why most of the mountain climber, when you try to watch them as they go to higher mountains such as in Everest, um, they try to bring their own oxygen tank because when they reach higher elevations, they are having hard time to breathe because the particles are really sparse and really few. So with that, they bring their own oxygen tank for safety purposes as they reach this high elevation. So with this, if you have few particles, which means there will be less particles that will absorb directly the heat that is coming from the sun. So it is cold because there are no or few particles that will absorb the heat that is coming from the sun. At higher altitudes, here on the troposphere, air temperature normally becomes lower. Air or atmospheric readings are also made at ground level. So, atmospheric pressure. Atmospheric pressure is sometimes referred to as barometric pressure because its measurement requires the use of a barometer. The normal air pressure at sea level is taken as 1 atm. So what do you mean by sea level? So that area which is actually the same level with the ocean, such as our ground, or this one, the area that you are setting your foot and same level with the ocean, you call that a sea level. And the normal air pressure with that is 1 atm. That is the standard. A modern type of barometer is actually aneroid barometer. Aneroid means not containing liquid. So there is no liquid inside that instrument. Instead of a liquid, it uses a metal that expands or contracts in response to air pressure changes. So usually the type of metal that is placed in there is highly sensitive to pressure changes. Air has pressure. Okay? What do you mean by that? Pressure is actually force exerted over an area. So, since it's actually a type of matter, all types of matter is having this force exerted over an area, or also known as weight. So, these particles, since we are having gravity or force that pulls any type of matter towards the Earth's center, all the particles are being pushed towards the center of the Earth. Thus, the pressure is concentrated near the ground. Okay? Therefore, air pressure is greatest at the bottom. Just like what I've said a while ago, since they are being pushed towards the Earth's center, most of the particles are here located on near the ground level. That is why when you go to higher elevation, like in Baguio and Tagaytay, there are only few particles on that area because most of the particles are having a pressure towards the Earth's center. Okay? The pressure of air changes when the temperature changes. So they're actually correlated to one another. In the atmosphere, warm air has low pressure. Okay? Again, warm air has low pressure, while cold air has high pressure. So which means when it is hot, there are few particles interacting to one another or exerting force over an area on that particular location. And then when you have cold air, such as in Baguio and in Tagaytay, it has high pressure or there are a lot of gases exerting a pressure over that particular area. So cold air has high pressure. Next, factor affecting weather and climate is actually humidity. Humidity is referred to the amount of water present in air. So, this is actually amount of water vapor or the gas present in air. It is measured by an instrument called hygrometer. The rate of evaporation depends on the temperature. So for sure, if you have water evaporates at 100 degrees Celsius, lower than that, you will not reach humidity because water evaporates at 100 degrees Celsius. So there will be no water vapor lower than 100 degrees. So you wait for 100 degrees Celsius until such time there will be this water vapor present in air. Okay? The water vapor content of air varies per location. On a hot, humid day, air can contain much water vapor because it's hot. Okay? So when it is hot, there will be a lot of particles that will evaporate. Thus, when there are a lot of particles that will evaporate, there are a lot of water vapor that is present on air. So it is humid. Okay? Kasi nga, when we speak of humidity, it is the amount of water vapor in air. So when it is hot, a lot of particles will evaporate on air, and then a lot of, if there will be a lot of water vapor in air, then humidity is high. Okay? Now, cold air is dry. So there will be no water. Because when it is cold, there is no evaporation. So when there is no evaporation, there will be no water vapor and contains little water vapor. Thus, when it is cold, the humidity is low because there are no or few water vapor in air. Okay? Next factor that is affecting weather and climate is actually cloudiness. Clouds form when water vapor rises, gets cooled, and condenses into water droplets or ice crystals. So when you speak of cloudiness or clouds, these are just ice crystals that condensed on the atmosphere. But to be specific, on colder region of the atmosphere, because when water vapor reaches this area on the troposphere, diba? When we speak of troposphere, as you go to higher elevation, the temperature gets cooler. Now the thing is, when the water vapor, as they evaporate, water vapor means it's hot. It comes from a hot condition, because you could not have a water vapor when the temperature is low or it's cold. So there must be a hot temperature for this water to evaporate. So from hot water, so you have water vapor, but as they go up, as they go up the atmosphere, since it gets colder, diba? As you go to higher elevation, the temperature gets colder, like in Baguio. So the thing is, when they reach this area which is cold, they condense, they cool down and precipitate and forms ice crystals. Now, when these ice crystals accumulate to one another, they form into a large masses. Now you have a cloud. So basically, when you speak of clouds, these are accumulated ice crystals. Okay? As more and more water droplets, clouds accumulate and become heavy and may precipitate as rain. So when this accumulated ice crystals gets heavier, and they could not withstand their own weight, they drop down in the form of rainfall. The general types of clouds are the following. Cumulus means heap. Heap means heavy. Okay? Stratus means layers, or strata. Strata means layered. So when you see clouds that are actually in layered form, or there are lines in between, so you call that one as stratus clouds. Next is actually cirrus. Cirrus means curl. Okay, so these are the types of clouds that you will see in the sky, which is actually curly. Usually, cirrus clouds are actually high type of clouds. You will observe this cirrus clouds when you are actually in an airplane, and then as you view on the window side, you will see, or you will observe, a curl structure type of clouds. These are actually cirrus clouds. Okay, because most of it, not really most, cirrus clouds are actually high type of clouds. Okay, next is actually nimbus. Nimbus means rain or dark. So when it gets dark, next to that is actually rainfall. Next is actually winds. Winds are moving masses of air. Okay, how do we have this winds, or how do we move these gases? Winds move from a place of high pressure to a place of low pressure area. So when we remember our discussion on air pressure, pressure means a force exerted by gas over an area. Now, when there are a lot of particles over this particular area, the tendency is that from the particles move from high pressure going to a low pressure area. Now, with this, you have already a movement. Okay? Now, when there is a movement of gas, you already have winds. Okay? Differences in pressure are caused by differences in air temperature. Because again, remember, low pressure area, you have high or hot temperature. If this hot, the pressure is low. Now, if it is cold, the temperature is high. Okay? So, which means there are a lot of particles exerting a force over an area if the location is cold. Okay, now the tendency, if you have a high pressure area, particles will go from higher pressure to lower pressure area. So the movement would be from cold going to hot area. Okay? So in effect, air moves from cold places, just like what I mentioned a while ago, to warm places. Okay? So what elements of weather and climate highly affects it? So temperature, number one. Temperature changes result in air pressure differences. So as the temperature changes, the pressure in the atmosphere changes. Now, with this effect of temperature, and then there is an effect to pressure, likewise, there will be an effect to winds. Okay, it's actually a domino effect. Okay, Evaporation and humidity increase when temperature is higher. So we will not experience high humidity if there is no evaporation process or if there is no high temperature, because water evaporates in a high temperature. To be specific, it should be 100 degrees Celsius for water to evaporate. So there will be no humidity if this particular area is cold. Okay? Now, winds are a result of air pressure differences, which are caused, as already mentioned, by temperature differences, and likewise is connected to pressure differences. So, that would be all my topic for today. I hope you learned something new. Again, let's have a recap on my discussion. The composition of the atmosphere is basically 78% nitrogen, 21.9% oxygen, and the rest of it, which is actually composed of carbon dioxide and some inert gases, which is found on the group 8A of the periodic table, such as helium, xenon, radon, argon, and the likes. Okay. Next to that is the elements, the difference between weather and climate. Weather is the change of atmosphere over a short period of time, whereas climate is the change in the atmospheric condition over a long period of time. Now, there are a lot of factors affecting weather and climate, or the condition of the atmosphere. Of course, number one is temperature. Next would be pressure. Next would be humidity. Next to that is actually precipitation. Next to that is cloudiness. And the next would be winds. Okay? So, again, that would be all for today. Goodbye and thank you.